Hey, Brendan.
Hi.
So today, Dr. Lobo's probably going to come in about 11, maybe 11:15 or so. So because I scheduled you for today from
to 11:30.
Yeah, but it's not. But you're only doing 3 hours, so just
I'm only doing 3 what?
3 hours.
Oh,
Yeah.
Okay.
So just do what you can, and when he gets here, just know that
I'm done.
Yeah, exactly.
Okay. All right. All right. That is fine. I'm probably gonna. All right. Well, we'll see if we can get this done. Should be fine. Well, I mean, luckily Jamie already went over some Newton stuff, so I might be able to go pretty quick through some of the stuff.
Yeah, we're actually a little bit ahead of where we would normally be, or where we have been historically.
All right, let me get set up here. All right. Buddy. Why? Apparently, Newton doesn't exist anymore. That's cool.
No big deal.
Apparently not. Always something dumb. Maybe the VPN is messing up.
Good morning.
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 Okay. Yeah, the VPN is just crap.
Oh, by the way, when you log into the VPN, Jamie told me that now the first part of the login handle or the login server name is secure dot. Did you know that?
No.
Yeah.
For the IP?
Yeah.
Oh, they changed it.
Yeah. For the VPN, that is. I guess they migrated or something. Yeah, I don't know. Who knows?
Well, if it still works, then whatever.
That's exactly what I told him. I was like, how is anybody's mine still works? How was I supposed to know that?
Yeah. I guess when they eventually made it not work anymore, you're supposed to know that.
I'm kind of curious, how recent was that change?
Honestly, I have no idea.
I'm tempted to think that was why I couldn't use my main machine for CS1.
I mean, I'm using the VPN and I'm connecting with the old one. So,
Ethan, when did you take CS1 with Zoom?
Last semester.
Okay. I took him last fall.
Yeah, he was an experience, to say the least. Very good one, but an experience.
That was
Yeah.
advanced game. Yeah, he'll teach you. You'll actually learn.
Yeah, when I was studying for the foundation exam these like past couple months, I was like, dang, I actually like remember most of this stuff. which was nice.
Or you could just be a computer engineer and do all the same classes and not have to take the foundation exam, like me.
Oh no, I was a
Or-
computer engineer, and then I took linear circuits 1 and was like, not for me.
Yeah,
Or-
I mean that is true. That is true. That's a very honest statement there. I could. Oh god, that linear circuits 2 would. Well, you said 1 or 2.
I said 1, so I didn't
Yeah.
even get to.
Oh yeah, 2 is a lot more fun. I mean, yeah.
Oh, gee. Yeah, no, like I got a B in 1, and I don't know why my professor decided to turn the final exam difficulty up to 11 because he had to make it online.
Nice.
And I was like, dude, what are you doing? Like, making this open notes does not help at all.
It actually,
I mean-
sometimes that actually messes you up because you're like spending all this time trying to find stuff in your notes.
Yeah.
Yeah.
Have any of you guys ever taken Chan?
Yeah, I had Chan.
Yeah, Chan. He is the worst best professor ever.
Totally, I
Yeah.
totally agree. That is the best
He
way to
is-
describe him.
Yeah, he is. He will. You will learn from him, but you will not get an A in
Suffer
his
for it.
class. You will not. Yeah, he is.
What
he
did
is
you
very
take him for, Brandon?
Well, I had him 3 times.
Did you take him for
Yeah.
DSP?
No, I don't need to take DSP, and I did not. DSP I heard is the hardest. I took him for linear circuits 2, linear control systems, and oh no, it was just twice. I thought I had a different professor for E1, but he teaches E1 as well. So, but
I
had him
took him.
twice.
Yeah, I took him for DSP, and
Yeah, I
Yeah.
heard that's like the hardest class he has.
yeah.
Yeah. Yeah.
I
Well,
mean, it's good. You're absolutely right. The way you're describing it is literally the way it was. But
I mean, I don't regret ever taking him, but it's definitely the closest I ever came to failing a class.
that is so
I-
true.
But no regrets. I learned a lot from him. So I probably would regret if I failed. But linear control systems I took last semester, I came pretty close. I was close. It was hard, but luckily, I did really good on our project, and a 10-point curve helped. So it worked out. All right. Well, are we ready to get started then?
Yeah, go ahead.
All right. Well, I'm just going to post a tutorial here. We're starting 3. So today it's going to be all about setting up your environment and using Newton. So you already have some experience using Newton. So, I mean, that's good. So we should be able to kind of go through some of this stuff quickly. I'll probably spend more time on the environment setup with Anaconda. So for everyone here, who is everyone using MOBA Xterm? Is there anybody doing it from the command line like I am? Who's using the
Two-
command line?
2 Mac users. The rest are MOBA Xterm.
Okay. Wow. Okay. So I have a whole section here. I'm going to talk about transferring files to and from Newton. MOBA Xterm pretty much does that for you. There's a file explorer in there and allows you to just drag and drop files from your local to the Newton and then back and forth real easy. So you pretty much don't have to worry about this section. So I'll just quickly go through it using the command line. Just the 2 different ways to do it. So for transferring files, you're gonna need to do this a lot. If you're mobile extern, you're already cool, so you can just relax for a few minutes. So there's 2 commands. So there's SCP and SFTP. So SCP is just transfer files non-interactively. So it's just like one command to transfer a file or a folder to Newton or from Newton. And then there's SFTP, which is an interactive program that allows you to kind of look through the file systems, grab them one at a time and stuff. So both of these use different protocols. So if you want to learn more about them, you can look them up. But yeah, let's just go over SCP real quick. So say I'm on here, or I'm on my local computer. So let's get back to the local computer. The basic syntax is SCP, and I want to move a directory. SCP tick R, and I want to move some file, or file directory. And remember, tick R is recursive, so you need that if you're going to transfer a directory. And then some type of local directory. And then you want to transfer it to Newton. So in this case, from the command line, if you already had to set it up in your config and stuff following the part 1 of this tutorial here, and you have your host name as Newton, you can just do Newton : and then wherever you want Newton. So it's going to start in your home directory. So we just do Newton dot. Remember, dot is just whatever the directory is. In this case, will be your home, because when you log into Newton, you always go into your home directory. So this is where it'll start. But you can also type a path here if you want, if you know the path, and that will SCP into move a local directory. And then now, if you want to do the reverse, it's very simple. You're just going to do Newton, and see, I already have something here, Newton, and some file or directory, and then you just put it in your local machine. So if you want to move it into the current folder. That's pretty much it from SCP. Just moving files around. And if you don't use tick R, you can only transfer files. You need tick R for recursive. And then there's Sftp. So Sftp Newton. So this is a more interactive program here. So when you SCP, you're going to get a different prompt than your normal, like this thing here. So SCTP allows you, has its own commands. So you can use some basic commands like ls, pwd, and cd. But now, and that's moving around Newton. So if I want to move around my local directory, I'm going to just put L in front of these. So if I do lpwd, you can see I have my remote working directory and my local working directory. And if I do like lcd, then I'm going to see my local directory. I guess I don't want to see that. I want to show you guys that. But lcd is for that. And you can do lls. Oh, because I meant lls. LLS is like a directory, LCD to move around your local directory. So yeah, don't look at all my weird files. Yeah, so that's pretty much it. And then if you want to put a file, you can use put. That puts a local file, and then you put it wherever you want here, remote, so where you want it in Newton. And then if you want to get a file, it's just get. And then remote file, and then you can put it wherever you want on local. So but since most of you using mobile Xterm, you just use the file explorer, and yeah, you pretty much don't have to do any of this. But it's good to know these commands because you'll be using it often. I would say SCP is a little bit faster than SFTP because then you have to like move around and stuff like that. SCP, if you just know where you want to go, you can just quickly type it into new files. Well, feedback loop there. Okay. A little scary here. All right. So that's pretty much it for transferring files. Go ahead and give it a test now. Make sure you guys can do that for the 2 unfortunate Mac users here. Yeah, so that's pretty much it, transferring files. Nothing too bad. You can also, if you're on Windows, if you don't want to use MOBA Xterm, there's also a program called WinSCP, which all it does is for transferring files. It's like a whole interactive thing. It's a pretty nice program. Works pretty well. So you can use that too. Yeah, but if you're on like Linux or Mac, it's better. I recommend learning from the command line because the more you learn from the command line and stuff, it means you don't have to rely on any other programs or stuff to do what you need to do. You can any command line you could drop in on any computer and you'll know what to do and how to work it. So all right, any questions on transferring files? All right, cool. Well, then let's get to the juicy stuff and get to environments. Let's go ahead and log into Newton. So everyone, however you log into Newton, go ahead and log into Newton. And let's take a look at how environments are configured. So there's two parts to your environment. You're going to have modules and you're going to have your Anaconda Python environment. So starting with modules, the way Newton manages all different versions of programs and libraries, it uses a thing called modules, which are specific programs, and they have like tons of versions of all these programs so you always have the right one available for whatever you're doing. And this really makes it nice. You don't have to mess with path variables or fixing weird environments and stuff. It'll just, every time you want a different environment, you load the modules you need and you're good to go. So if you want to take a look at what modules are available on Newton, you do module avail, and you'll see a very large list of modules. You can scroll through here. So most of these you probably won't use, but they're all here. The only ones we probably need is CUDA and Anaconda, which was up here. Somewhere right here. Those are pretty much the main modules you're going to be using. And CUDIN, which is somewhere over here. Somewhere over here. So if you want to quit this thing, you just type Q to quit this little listing. So let's go ahead and load some modules. So first we're gonna configure an Anaconda environment. So we're gonna want to load Anaconda. So let's load Anaconda, and we're gonna load Anaconda 3. And if you see this, that means you loaded it properly. So Newton has a bunch of built-in environments and stuff in the Anaconda, like default environments. It has a lot of programs and things like that. So we'll get to that in a sec. So for finishing up modules, so if you want to see what modules you have, module list, you can see are loaded. So if we load CUDA/CUDA, I think it's 11.0. Yep. So now you can see we have Anaconda and we have CUDA 11.0 loaded to use. If we want to unload a module, you can do unload to unload a specific module, or you can do module purge to clear all modules loaded. And we're going to keep Anaconda loaded. So that's pretty much it with modules use. I mean, mainly you're going to be loading probably these two modules, and that'll be the extent of what you use. So, but if you need any other ones, there's like, I think, they have Cafe, CMake, some, pretty much any program you need is in there. So, so now that we have our Anaconda module loaded, we can start working with Anaconda. So I know that you guys might have some issues configuring your Python environments, maybe locally already, but using Anaconda is pretty much the way to go. You don't want to use any type of, or you don't want to use like just your system environment, like your system Python environment, or just some type of default environment, because what's going to happen is that you're going to realize that, like, okay, well, I want to run this one code or this one program that requires some older versions, but all my other programs require the newer versions, and I can't install the older versions. Now, what do? I can't run this code. So Python environments completely fix that, because you just have an environment with all the correct Python version and package versions you need to run whatever code it's meant for. So I'm guessing did you go over, Robert? Did they go over like Anaconda already, or is this like the first time, like official tutorial?
No, we've done all the Anaconda stuff locally.
Okay. So what, you've been using like the GUI, I assume?
Yeah, so some of them are using the Anaconda prompt.
Okay.
But I mean, I'm trying to keep everything to some form of command line. So
Okay.
terminal
Okay,
for Mac users, and then Anaconda prompt for the rest.
All right. So in the link, there is a Anaconda starting tutorial link that I find is pretty good, and you can click that. Just have some extra tutorials there. Remember that for what I teach yesterday, and besides all the Newton stuff, when I'm teaching today with Anaconda, like there's infinite tutorials online. to learn stuff. So, you know, if you find that I'm not doing enough, or you're still confused, there's a lot of stuff online you can find to get some better, just to get some different perspectives. But I'm just going to go over pretty much the basics. I mean, there's ways for transferring environments, creating and, you know, installing from environment files and stuff, but we'll just keep it simple and just to get your environments up and running, especially on Newton, because Newton has some issues, to say the least. So what you can do first, so let's just start with creating a basic environment. I recommend you creating your own environments on Newton and maintaining them rather than using the environments that are on Newton already, because you can actually do Conda environment list, and you can see it has like a bunch of them already, like PyTorch CPU, GPU, TensorFlow versions. These are nice, but the problem is that you can't modify these. Like you can't install or add new packages to these because these are built into the system. So it's better just to create your own environment, and you know, so you can modify it and add what you want. Let's go ahead and do that. So very basic syntax for creating environment. We're gonna do conda create tick n. So this is gonna be this flag requires an argument for the name of the environment. So I'm just gonna call mine ML, which I might already have. I mean, let me actually make sure I don't have. All right, I already have an environment called ML. So we'll create a different one. You can call it ML, but it doesn't really matter what you call it. It's a name. I'm gonna call it test environment.
Hey, Brandon,
And
for the sake of singularity, can we call it like REU 2021? That's what I have them calling it on their local.
sure, we'll call it RU 2021. Python version 3.8, I hope. We'll use 3.8. I think that should be good for everyone. Now, when you're running this, you may get something like this or an aborted core dumped. So you're like, okay, well, Newton has a lot of memory. Like what's going on here? Well, the way Newton works is you have, did I go over? Is this number 3? Yeah. Okay. So I go over Newton more in the second one. So what happened here is that you need some more system resources in order to run Anaconda. This will tie more into the next section about how Newton allocates resources. But for now, we'll come back to it in a hot minute here. But pretty much by default, you don't really have any resources allocated to you. So you need to allocate some resources. So what we're going to do is we're just going to do the same command, but we're going to put srun in front of it. So we're going to do srun and then conda create again RU 2021. We want Python version 3.8. So this is a little bit of different argument you've seen before. So you've seen like flags and like just typing things, but this one requires an equal sign. So it depends on the program. So some programs, especially when you're configuring like using pip or Anaconda, when you're specifying versions, you'll use an equal sign. So I want to install Python in this environment, and the version I want is 3.8. You'll do the same thing with packages. So let's go ahead and run this, and hopefully Newton will be nice to us today, and it should work. Let's see. Yep. All right. So Newton, it'll do its thing. So it might take like a minute. So it'll do its thing. Now it doesn't say why here. Just press enter when you get to here, because there should be a prompt here, but it doesn't show up like to proceed. So just press enter, and then it'll start going. So this should take like 2 or 3 minutes. So let's go ahead and get that installed. And yeah, and there you go. So go ahead and give me like a check mark in Zoom or when you're done installing, so I can know everyone can see that we're all good.
I'm trying to mirror my local environment that we set up before, so it's going to take a little bit longer.
All right. All right, well, we'll wait for everyone except you then, I guess. You want to be cool and putting in your own things.
I'm not really cool. It's just the environment he had us set up locally.
I know, I'm just joking. Yeah, it'll take a little bit longer on Newton, so just gotta give it a minute. I know. I think installing PyTorch took like 5 or 10 minutes, just from what I remember.
Yeah, it's like 700 or 800 megs, I think.
Mm.
It's a really big package.
All right. Well, we got what, half so far. Gonna have it up. Installing. For everyone else, are you guys installing some extra packages?
Should we be?
No, I mean, I just want to make sure the environment's created and you see this. So once you get to here, just give me a check mark. So I know everyone is good to go. I know someone gave me a thumbs up, but it runs, the thumbs up goes away. So I'll give it like 1 more minute and then we'll get going.
Should we be installing the packages that we installed at the beginning of the program?
Yes. I'm just making sure the environment is, everyone can get set up first. Well, we'll get there. So if you want to go ahead and start installing some packages, you can.
Wait, Robert.
Yeah.
So I don't want to make like I don't have the same issues I had before where I where I installed TensorFlow, then Keras, then PyTorch. Should I just go with PyTorch?
Just PyTorch is fine.
Okay, that's great.
Yeah, in the event that your graduate student that you're working with uses TensorFlow or Keras, you can just make a new environment, okay?
Yep.
All right. So this is show. I don't think you need srun. You might need srun to actually install packages. So let's see. So we'll go over just installing a package real quick. I'm going to install Matplotlib. So this conda. So the syntax is conda install -c conda forward Matplotlib. But you got to remember, you got to do this in your environment. So let's activate. So as it tells us there, actually, I don't think you can use conda still. I don't know if they ever fixed that. No, they never fixed that. Okay. So I've tried doing the init and getting it set up, but it's never worked for me. So I just use source activate and it just works. So we'll use RU 2021 and you'll know that you're activated when you see this prompt here showing that you're using this environment now. And then now we can do conda. I'm just going to install Matplotlib real quick, which you probably will need. So Matplotlib. Let me see. If you get like out of memory or like an aborted core dumped, yeah, you're gonna want to use srun. So just put srun in front of it and it should work. Install. Yep. And then when you get to the screen, you just press enter. So it seems Newton's gone a little bit faster these days. Let's go ahead and I'm just going to install Matplotlib. So that's pretty much the same way to install. I mean, that's really it to your environment setup. As long as you don't do anything terrifying, you should be fine. And the thing with PyTorch and TensorFlow, so I think what you should do is you should, if you want to have both installed, I think the process is you should install TensorFlow GPU first and then install PyTorch, and that should work.
I did that. I gave errors. It like PyTorch installed the CPU version of TensorFlow and the CPU version of TensorFlow overrided the GPU.
That's odd because if you install TensorFlow GPU, it should read that you already have TensorFlow installed. You know, I know because I've ran into this problem before and I fixed it, but I haven't used it. I haven't done it in so long. I can't remember off the top of my head.
It says the verification has an error when I try to install it.
What has an error?
The verification translation. Can I do screen share?
Sure. I think I have to stop here. Okay.
So when I run this thing here,
Yes, because you see your environment location, apps Anaconda, you're using a default environment.
so I mean, need to create this environment first. I see.
Did you, okay, you didn't activate your environment. You see that there? You see CRV student 1 and user 1. You don't, you need to do source activate RU 2021, the environment you created.
Oh, yeah, I see.
Yeah.
Okay, thanks.
Yeah.
Yeah, I'm getting channel not available error. The channel is not accessible or is invalid, but I'm in the environment.
The channel's not available. Are you sure
Yeah.
you spelled it right? Here, let me share my screen.
Okay, can you probably paste the command in chat? Maybe.
It's yes. Make sure I'm doing the right thing. It's conda tick forge. So this is the command I use to install Matplotlib. So srun conda install tick c. This is the channel conda tick forge because Anaconda has different channels that you can install from that have different versions of packages and stuff or different types of packages. So these channels you can see as like, I don't know, like, so because like companies and stuff can make their own channel to have their own versions of like packages and stuff like that they need, so you can install. So that's the Conda Forge is like a default channel, but you should be able to run that install Matplotlib. But from here, once you have the environment activated, so you did source activate, remember to activate your environment. Source activate RE 2021. Don't forget that. You should see your prompt here showing that you're activated. You should be able to run your install commands like you've done normally. So if you want to install PyTorch or TensorFlow and stuff like that, I'll see if I can, maybe after the tutorial, something I can find what helped me to get TensorFlow GPU and PyTorch GPU installed. Because I know I've ran into that issue. I've done that before. I just can't remember from the top of my head how that fixed.
Should we be able to run the module load CUDA and Anaconda now?
You should have done that in the beginning. Because you need to load Anaconda before you do these commands. So module, right?
Okay, so it's saying please run conda and list
Yeah.
source activate, but I already did that.
Yeah, so that's fine. That's it. It just gives you a message when you load it. That's, you don't have to. Yeah, that's just, as long as you've already did that, it's fine. But once you load it, like if you do module list, you could see that it's loaded. So I already loaded it twice. So as long as it's loaded here and you're using Anaconda, you're fine. Yeah.
I have a quick question about
Yep.
PyTorch. So when we go to run the command, like you have to pick what like platforms you have and stuff. Would that be CUDA 10.2?
You can use CUDA 10.2, or as you saw, if you do module avail, there actually is CUDA 11 on here. Let me see.
Or they also have 11.1.
Well, they have CUDA 11.0 and CUDA 10.2. So
Okay.
I think CUDA 11.0 can probably work with 11.1, or you can just do 10.2 because they have that as well.
And should we be using Conda instead of? I'm sorry. Should we be using Linux instead of Windows for that?
For Newton?
For the on the website where you sorry, on the PyTorch website, they give you the option of either Conda, Pip, Lip, Torch.
Oh, so you
Wait,
should
no,
use
sorry,
Conda. So it should be Conda, Linux, and CUDA 10.2, or you could try 11.1. That might work, but CUDA 10.2, because there's not, they only have CUDA 11.0. So but yeah, it should be Linux, Conda. Here's the command. I think here it is for 10.2. I'll just paste this. This is in my tutorial here. So there you go.
Wait, do you want us to install it? Because that takes a lot of time.
Yeah, I would probably not do that right this second. So it will
Yeah.
take some time,
Yeah.
but so we can continue on. All right. So any more Anaconda questions? Anaconda is nice to, if you're nice to it, it'll be nice to you. So what's up?
When loading the modules, if you've
Mhm.
already gone into your environment, you can still just load the modules the same, right?
Yeah, the module loading and your Anaconda environment are separate. The only thing they're together is that you have to load Anaconda module first. But once you load Anaconda and activate your environment, you can load and unload other
Right.
modules.
Yeah, okay, that makes sense. Okay.
Yeah. But in order to use Anaconda, you have to first load the Anaconda module. That needs to be done.
So should we install the graphing, the PyTorch, and the Keras under the same environment or different environment?
You should do it all under the same environment.
I mean, you'd want Keras under a different one though, because at least in my experience.
Oh, for install. Yeah, if you're installing both in one environment, obviously has issues. So what you can do is we can just create another one like so we could do source deactivate to deactivate our current environment. Yeah, I know it's definitely.
So should I have like 2 environment and one for PyTorch and one for Keras, or should I have 3?
Yeah, you could. That's probably a fine thing to do, to have one for Keras and one for PyTorch. So let's just do RU 2021 TensorFlow. I'll just call it Python equals 3.8. Remember you got to use srun. Put that srun in front of it. It's also how you see how I'm moving real fast. By the way, I'm holding control and using my arrow keys, which skips to words, so I can move real fast when I'm doing it. That's why. So you can create another environment, RU21 TensorFlow, and then just install TensorFlow in this one. So it's already did it real quick, and then you can just do source activate RU. There you go. And then you can just do conda install. What is it? Conda install. This should be for TensorFlow here. And this is for installing the latest packages of TensorFlow. Like if you need to use TensorFlow like 1.15, I'm sorry that you have to use that. But yeah, you need to specify the version and stuff. But this is for the latest TensorFlow. That's just trying to mimic PyTorch, because we realized PyTorch was already cool. And like I personally recommend PyTorch, as you probably guessed. Is there any other questions about an Anaconda setup or installing? Make sure you use srun in front of the commands when you install packages or create environments. That's all. And then if you shouldn't have any problems setting it up.
How do you rename an environment?
How do you rename an environment? That is a good question. I don't think I've ever done that, actually. Well, we can always do conda help and see what we got here. I'm not sure you can do conda environment help. Please give me some help. Oh, okay. Give me invalid. You might be able to create list. You know, you might be able to just actually change the folder name, and it might actually work. Let me see here. So I have my environments here. So let me move. Let me just try moving RE TensorFlow. I renamed it. Well, I gotta deactivate. Deactive. I can't spell. Deactivate. Thank you. Oh, there you go. There, that's how you rename it. You can just move the folder of the environment wherever you store. I store mine in my environments, but I think by default it's they're stored. They should be stored in Anaconda / environments. I think I can't remember where they're stored. In your home directory. So you can do ls.a and you can look through all your stuff. There should be something like .conda / environments, and you can just rename it. Yeah. All right. Any other questions? No, all good. I know Anaconda environment setup can be annoying, but it'll become second nature as you do it more. And using separate environments when you have conflicting packages like PyTorch and TensorFlow, you know, is usually easier than trying to just get them both installed in one thing. So, and it sucks having to maintain multiple environments. I mean, the only couple things like storage space, because the environments do take up a bit of storage and some overhead and stuff, having to switch environments. But at the end of the day, it'll save you a lot more pain than trying to do everything in one environment. So, yeah, I mean, that's the very basics. And you can like export environments. You can create like what's called environment files. So instead of having like to install the packages manually, you can create an environment file that has all the packages listed. And you're just like, hey, install this environment. It'll install all the packages you need. So you can skip that step. We're not going to get into all that because that's quite a long tutorial to do that. It's all in the Anaconda starting tutorial. You can look through that, but like creating environments from environment files and stuff. So if you're moving environments a lot, or if you're like switching computers and stuff, having an environment file can be nice to just quickly set up an environment wherever you are. But that's the very basics of just setting it up on Newton. Just install your packages, and once it's set up, you're good to go. And I'm going to go over to part 4 of the tutorial, and we'll get into some Newton specific, how to actually run our jobs on Newton and why we have to use SRun. All right, so I'm going to talk a little bit at you here. So I got to go over a couple things here for how Newton works and stuff. Am I about to sneeze? No, I'm not. Okay. So Newton will uses what's called Slurm. So Slurm stands for Simple Linux Utility for Resource Management. And as the name says, it's not a simple. So it's not a simple Linux utility for resource management, but as the name implies, but it is what is Newton uses, and pretty much most other clusters to distribute its resources, CPU, GPU, and memory to many users efficiently. Without any type of bottlenecking and stuff. So when you run things on your local computer, you just run a program and your OS will just take all the resources it needs from your computer and run the program. So when you're on a large server cluster like Newton, you don't want one user taking up 192 cores, 8,000 gigabytes of RAM, or 20 DPUs. You want them taking up all that. That's where Slurm comes in. And I mentioned server cluster because probably it was already explained to you, but Newton is not just one computer. It's a cluster of what are called nodes that are linked together. And so there's a user node which holds your data and user files. And then there's a bunch of compute nodes that has the GPUs and the CPU and the RAM all attached in there to use. And so Slurm allows it to manage all of those nodes and assign people like, okay, I'll give you this node's available, so I'm gonna give you this node with these amount of resources, and that's how it works. And that's why when we log in, we see where our host name is EV user 1, because this is our node we're actually on. But the compute nodes are called different nodes. They're actually like separate computers with their own operating system and stuff. We just never see that because Slurm manages that for us. And the diagram got removed in my tutorial, but we'll fix that at some point. So I don't know if this is updated. If they probably added more stuff, but at the time the tutorial was made, there's 20 compute nodes. Each node has 32 cores and 192 gigabytes of memory. Each node has 2 NVIDIA Tesla V100s. DPUs. So these are $10,000 DPUs. They're pretty cool. So total 640 cores and 40 GPUs. Half the nodes use 16 gigabyte VRAM cards, and the other half has 32 gigabyte VRAM. That might have changed. There might be more resources, but that's what we're looking at here. This is a very expensive cluster. So 40 GPUs at about $10,000 to $11,000 each. It's a little bit expensive. So Slurm manages all that. You can kind of think of it as a printer queue. It's pretty much that, except more complicated because instead of just print jobs on one printer, you're managing, your programming and your code jobs across multiple nodes in a cluster. So from now on, just some terminology. When I say jobs, when I say I'm referencing the programs that are submitted to Slurm, to the Slurm manager to be run on a node. So that's when I say a job or jobs, I'm talking about the programs we submit to Slurm for them to run. And there's also a queue too. So there's a lot of people running jobs, and you're gonna put in the queue and have to wait until your program runs, which will definitely happen over the REU. You're gonna run into a lot of issues with that. So good luck. So okay, so let's get back to Newton here. So let's go over some commands about how we can see what resources we're using. So first of all, we can do my usage. Oh, okay. Yeah, so you have to deactivate from the Anaconda environment because they still use Python 2 for this script because they're really cool. All right. So let's purge actually. Let's purge all of ours. Make sure we're not loaded, and I think it should work. Nice. Yeah. Yeah, so you have to deactivate from everything and purge your Anaconda, the Anaconda module to use this my usage command because they want to use Python 2 and not ever update it to Python 3. So yeah. But this command is a script that actually was created and put on Newton to go over the usage for the account. So this is going to be different than you guys because I'm on Dr. Shaw's account. So I'm going to have a little bit more resources. As you can see here, there's a lot of people using. Wow, that's some high usage. Holy moly. Poor CPUs. Wow. So, but you're going to see some different things. You probably won't see any usage from people because I don't know, or you might have used Newton already, so I don't know. But yeah, so this goes over your usage for your group. So now it's not just you that has a maximum CPU and GPU hours used. It's all of your students here today have a total of CPU and GPU max. So as you can see here under my the Dr. Shaw account, can use 100,000 CPU hours and 16,000 GPU hours, and it goes over the percentages. But for you guys, no, what do you guys are saying? It's probably like 2,000 and something.
I'm still getting the message print usage for account.
Yeah, make sure you do module purge. You have to completely unload the Anaconda module. You should not have it listed here.
Yeah, I did that.
Are you still activated in your environment?
Yes.
That's the problem.
Okay.
Yeah, but since you unloaded it, I don't know if you can deactivate it. So you might have to reload it and then deactivate your environment. Yeah, you can't be in any environment, and you can't have Anaconda loaded to use this program because it uses Python 2, so it has to be on. Yep.
How do I unload Anaconda? Sorry, I missed that.
Well, there's two ways. You can do module unload Anaconda 3 just to unload that specific module. But if you just want to unload all your modules, you can just module purge and I'll unload everything. So there's two ways. So if you just want to unload one module, you can just do this like that.
Yeah, the first one worked, I think.
Yep. And then once everything's unloaded and stuff, my usage should work.
I got a question about the used limits and stuff. Is that like a quarterly, like
it's
does
right
it
here.
Like reset?
It's monthly. It's monthly.
It's monthly. Oh, okay.
Yeah. So this is a start and end here.
Monthly.
So
it's monthly, Michael.
Yeah.
Okay. Right on.
Yeah, and you'll see that right here. This is the start and end period. I'll give you. Yeah, so you'll have to beg Robert to then beg Jamie to probably increase your limits during the semester. So that's gonna happen. So be ready for that. All right, so everyone's able to run my usage. We're good. All right, so, and this is cool because you can see everyone on your account using, so you can see if your fellow peers are hogging up all the resources and you can go beat them up if you need to. So actually, you're over the internet, so maybe not. But
So just as a good idea before we have like a large project we want to run, the first thing we want to do is make sure we have available time,
yeah.
right?
Well, yeah, you can look up to make if you're increasing your limit, you'll be able to get more. You have to just tell Robert to tell Jamie to increase your limits, but you shouldn't over the REU semester. You should not, or this summer. I mean, you shouldn't have to worry about running out of resources and not having any more. They'll just give you more. So, but I don't know why. I don't know if they just give a lot at the beginning. It should tell you how many hours of CPU and GPU do you guys have. Just curious.
45,000.
5,000 for both.
45,000 for CPU, 8,000 for GPU.
Oh, 8,000. Oh, okay. Then no, I don't think you guys will hit that then.
Yeah.
In my semester they gave like 10,000 and like 1,000 or something the first month. We're like, yeah, buddy, this ain't enough. So yeah, but that should be enough. But if you do end up if you do see that you're approaching the limit, you shouldn't have to worry about big jobs or anything. But if you see yourself approaching the limit, just make sure in advance you get that and get some more limits.
It says I've used 365 hours already, and like,
yes,
I haven't run anything on Newton yet.
Yeah, I'm wondering that. I think they still need to reset them from last year, maybe. I think Jamie said that.
Nah, I don't know. I really couldn't tell you. I mean,
I have some difficulties of getting into my usage.
Did you deactivate everything and then load Anaconda?
Yeah, I deactivated the environment and I purged the models as well.
You can just log out of Newton and then log in a new terminal, and I'll just clear everything, and then you should be able to use it if you're still running any issues. Yeah. So that's for usage for that. You can also now we need to look at our hard disk usage. So hard disk is going to be my quota. So this is not shared with anyone else. This is your usage on your user account. So this is all the usage all the files you have in your home directory here. So my quota here, as you can see here, I have 500 gigabytes. I don't know what your quota is, but this is the max. You also get some grace periods. So my limit, I can go 10 gigs above 500, but once I hit that, I'm gone. And I can see here, I'm actually already approaching that limit. So you need to definitely keep a watch on this, because you'll run into errors like, run out of storage space. It just destroys everything. So this is something you want to watch a little bit more closely to make sure you're not hitting. Using my quota. Lee, were you able to use my usage?
Oh yeah, I got it. Yeah.
Good. The same thing with my quota. It can't be activated in any environment. You can't be loading Anaconda. If you're having difficulties, you can just log out, log back in. It'll just clear everything, and then you just use it. All right. So yeah, just make sure you don't go over your quota. Otherwise, you could probably ask for more. If you really need more, you can ask for more. They should be able to give it to you. But that's something you have to ask, not for the group, but for yourself. So you just Robert can go through to Jamie to bump you up. So all right. So now that's going over the resources. Let's actually get into Slurm. If there's no other questions, because Dr. Lobo is slowly approaching, so I need to get finished with this. Also, if you want to see, you can do DF, tick H, and you can see all the storage they have. So you can see here 368 terabytes, kind of cool. So you can see, so this is all the storage they have for all the users. They have 368 terabytes. That's kind of cool. All right, let's start going over Slurm. So I'm gonna go ahead and clear this out. Let's get some information about what's available to us. So if we type in sinfo, we can see some information about what's available. So normal is, so for the partition here, for this here, and I'm following along in the tutorial here explains this. Normal is a default partition. Preemptible is a partition that doesn't charge against an allocation, but on which jobs can be preempted. And then display, which is for Newton, which is for Newton, is a special partition set aside for machine in their workroom for display purposes. So it's basically not used, which is one node here, EVD1 for display. So as you can see here, you have your user nodes that you saw EV user, and then you have EVC for all the compute nodes. So the compute nodes start with EVC. So as you can see here, you have 16 nodes here in the state of mix. So the state here, drain means it's offline. Down means it's down, which we don't have a down one. Mix means some of these nodes, but not all of them are allocated. So as you see, you have 1 to 4, nodes 1 to 4, nodes 9 to 10, and nodes 12 to 21. Total of 16 nodes. So you have 16 nodes that are up in their normal partition. You have 16 nodes that are preemptible, which are actually the same nodes. Okay, so they're the same. And then you have some other ones. So as you can see here, you have nodes 5 to 8 are actually idle. So idle means that no one is using them at all. They're completely free. Mix means some of them. And then if you see something that says alloc, which we do here, that means this node is completely busy, 100% used. You cannot use this node. So that's just for seeing what's available right now. Let's actually look at what jobs are running. So we're gonna do SQ. So QUUUE, you probably know that from Zoom Lansky's, him saying that all the time. So SQ, we will run this and we'll get a queue of the jobs running. And we can see who's running them. So we can see some RU students already running some stuff here. For 13 hours, that's pretty cool. Whoever RU students at. You can see who the user, or this is the job name, and then this is the user here, the time it's been running for. So this is 1 day, this 1 dash, and then what nodes they're running on. So you can actually run things on multiple nodes. Like if you need to eat resources for breakfast, you can run it on 2, 3 nodes and use like a bunch of GPUs. But in your time in the REU, you probably won't use more than 1 node. But you can use multiple nodes if you need like 4 GPUs and it's tons of resources. So and then the state. So in this here, you have R means running. So all of these are running, but there's some other ones. You have PD, which you'll see for pending if there's jobs. So right now there's enough nodes to service everyone right now. So there's not any issues with doing that. But say if you want to run like 10 jobs, you can only have you have a max job limit. So once you reach your job limit, I don't know what that job limit is, your jobs will turn to pending until your jobs finish, and then your new ones will go into queue. Even if there's resources available, you have a limit on how much jobs you can submit it and how many, not only how many jobs, but how many resources you take up. I think it's not by job limit, it's resource limit. So if you have a bunch of small jobs that don't take up a lot of resources, I think you could do that. But once you reach your amount of resources you can allocate at once, like say they only allow you to allocate 4 GPUs, we try to allocate, and so you have 1 GPU per job, and then you have another job you submit, you use a 5th GPU, then it'll be pending until your other jobs finish. I don't know if 4 is actually your limit. I don't know what the limit is to your power, but yeah, just so you know, you'll see depending if you do reach that limit. This is how many nodes are allocated, and then the nodes that are actually being allocated. So you can see jobs can actually run on multiple nodes. So these 2 jobs are running on the same node because they're probably only using 1 GPU each, if they are using GPUs. So yeah, or if they're not using GPUs, then you can actually allocate a lot easier. So you can only cancel. So if you want to cancel a job, you can only cancel a job that you're running. So the cancel is this S cancel, and then the job ID. So these are the job IDs here. So you'll need to copy this and then cancel it. I can't cancel this job. Actually, I think if I try canceling it, I'm actually scared. Yeah, you'll get a permission denied because that's not my job, so I can't cancel it. But if for your jobs, that's how you cancel it. But let's learn more about information about a job. So what is a train SSL here? We're gonna learn more about this guy's job. All right, so we can do S control show job. And so S control is for controlling Slurm. These are subcommands. So these, you can kind of call these subcommands. So you have like your main command, the program you're running. And you know how you have like conda create and conda env. Those env and create, those are like subcommands. So they're commands within the main program. So I'm going to do S control show job. So I want to show this job, and I'm going to type in this job ID 97506 that I copied, and we can learn more about it. So we can see that the job name's train SSL, the user is priority, the account, job states, how long it's been running for, submit times. We know exactly when this job was submitted, which looks like at midnight. Poor guy. Let's see, anything else interesting? How many resources he's using? So 1, 4 CPUs, 1 node, 1 GPU. So this stress GPU, that's 1 GPU. The command he's using, so we can actually see his code. That's kind of cool. Fix PyTorch, train Slurm. Yeah, it's pretty cool. So you can learn a little bit more about other fields down. So if anybody's trying to run a job in secret, there's no secrets on Newton. Well, everyone can see what you're running.
Hey, Brandon.
Yeah.
Since we're coming up here towards the end,
yeah.
Do you think it would be possible to just get them, because they're having a little bit of trouble right now with the Slurm script, like how to load?
That's literally next what I'm doing.
Awesome.
Yeah.
Okay.
All right. So that's for just some basic stuff, but Slurm, but let's get to the juicy stuff. So there's actually an example script in that's like a big, it's a big script, but I'm going to go through it pretty much and go over like running it. And it has some nice things in there to try to manage your job logs and stuff. So there's 2 ways to run jobs. You have srun, which we saw before in Slurm. So what srun does, it allows you to submit jobs to Newton, but interactively from the command line. And sbatch requires a script file that you submit, and it runs, and it could, like, I remember we talked about scripts yesterday, a bash script to the file to run it. So probably Jamie told you, but srun's highly discouraged. They don't want you to use srun. And the reason why is that you can use it for like testing your code to make sure your code actually won't error out before you use sbatch, because it's really annoying when you submit a batch for a job for the night and go to sleep and it never ran because it errored out like right when it started and you didn't see it. So srun is good for testing your code interactively, but the problem is that they don't like you using it for long running jobs, is because once your job finishes, it actually keeps the resources allocated in your terminal until the terminal exits out. So it's like hogging up resources that you're not even using. So they'll cancel jobs that are running with srun for a long time. So this use it to test, but not for running for a long time. You want to use sbatch for that. In order to use sbatch, we have to use a Slurm script. So there's an example script in here. I'm going to break this down, make sure I have enough time to go through all of this. It has some niceties you can remove if you don't care for them. But I'm going to use a terminal text editor. I'm just going to paste this in here. And actually, I think I have my sample doc. So I don't know if this is different because I think I edited this one, but I'll just make sure. So you can go ahead and copy this and then save it to a script file. And then on your, again, the sample script file just as a template, and then we can edit it as we go through for an example job. But I'm going to go through this real quick.
Where'd you get this from again? Sorry.
I posted the link.
Oh.
It's the GitHub link. It's towards the bottom. So I'll just give 10 seconds to copy it, and we gotta make sure we get through this. All right. So first off, in your Slurm script, you have all these. You're gonna start off with all these. These are not comments. They're comments, but they're not comments. And what these are, these define the resources to allocate when you do pound sbatch. This is special for Slurm to define the resources you allocate. So these will define all the resources you need. So how many nodes we need? So what we need to do is that if usually you only need 1 node, but if you need to use more than 2 GPUs, you have to increase the number of nodes. You remember I said every node only has 2 GPUs available. So if you're using more than 2 GPUs, you have to use more nodes. But you shouldn't. I wouldn't. If you're really needing more GPUs, reach that bridge when you get there. But for now, let's keep with nodes 1. You have CPUs per task 1 and a number of tasks. This is increasing it if number of tasks in GPU for 2 GPUs. And increase nodes if you want more than 2 GPUs is here. So because when you have multiple GPUs, it has to parallelize that. So these are the number of tasks you have. So you're using 1 GPU, you just have your main task. You have 2 DPUs, you have 2 tasks, so you increase this to 2 if you want to. So please do 2 and then 2 if you need to. And then each of those tasks here, those GPUs will get four CPUs. And then for every CPU core that you have, you'll get this amount of RAM in megabytes. So this is 8 gig of RAMs. So this configuration here will give me 4 cores, 32 gigabytes of RAM, and 1 DPU. But if you increase the number of tasks, then you're going to get 8. It's going to double your CPUs and double your RAM. So you want to take that into account when you're doing that. It's the amount of time. So you need to make sure you set this because by default it's 10 minutes. So if you don't set the time, it'll just cancel your job after 10 minutes. I just put here 5 days. If you have a job running longer than 5 days, put that here, but I just set it to 5 days and they'll just exit before that. But it just makes sure that there's enough time set so it doesn't get canceled because of time. So this is hours, minutes, and seconds. So I did 120 hours, 5 days. And then this is for your job name here. And let's go ahead and I think I go over how to actually run this. Yeah, okay, in a tutorial. So let's go ahead before I keep going here. This is for defining it, but or defining the just some stuff here. But this is some extra stuff I do in my thing to make in the script to make things look a little bit nicer. So I'm gonna save this file, or I already have it saved, but I'm gonna create we're gonna create a test job and go ahead and submit that. So what I'm going to do is I'm going to, do I have any? All right, this is where all the stuff I had. So I'm going to make a directory called test job here.
I just
Hey,
tried
Brandon.
to.
Hey, Brandon.
Yeah.
Dr. Lobo is here. If you want to kind of move in the right direction. I know that we're at a very critical stage for the students, so.
Yeah. All right, I'll try to go as fast as possible. All right. So I'm going to go ahead and copy my sample job to my test job, and we're going to edit this script. So the sample script I have is just for, so I can just copy it real easy when I need to use a job. So I'm going to rename this to my Slurm. I'm going to create a Python file, vim, and I'm just going to have it just print hello world. This is something really easy. Hello world. Okay, so syntax is right there. And so now say this is our code we want to run test.py. And now we're going to modify our job script to run that. So in order to print hello world, we're going to need a lot of resources. So I'm just going to leave all this the same. And we're going to allocate 1 GPU and some RAM and stuff. So we're going to go ahead and add the name. So I'm just going to call the name hello world. And you want to fill a name as the same as job name here. So you're just going to put it in a couple of places. And this is just for naming your output files. So what these two here will do, well, so your standard out, your std out will output to this file. So it'll be hello world dot this %j is the job ID. So the slurm job ID. And then this is the out file. Then any errors will be logged here to the hello world dot job ID dot error. So we're going to select the file we want to run. So it's going to be test.py. Any arguments? We don't have any arguments. And then also one more time, fill in our name. I know it's in a few places, but this will make sure we have all the variables set so we can for the rest of it. So just quickly going through, this is how logs are stored. So when the program is done running, I actually have a directory called home bsilva job logs that are created that's created in order to store all my logs like by job ID and stuff to make it a lot easier for managing. Otherwise, those have logs everywhere. You can actually remove all of this if you don't want that to happen. But I'm going to go ahead and make sure you make this directory in your home directory. So as you can see here, this is an absolute path. It's typically better to do some absolute paths in the script. So there's no, because relative, you don't know where it's running, a relative path probably won't work. So you want to make sure you're using an absolute path, as we talked about. You got to make sure that this directory is created though. So you can actually, I'm going to exit real quick just to show you. If you see in your home directory, you can do make directory job logs. So I already have it here. But I called mine job logs. You can call it whatever you want, but just make sure you hard code that path. So here. So that's just for logging. Now we need to load the modules we need. So as you can see here, I'm loading CUDA 9. That's old school. So you probably want to use CUDA 10.2. And its OpenMPI is needed for if you're running on across multiple nodes, because that OpenMPI allows you to parallelize across nodes. But we're gonna skip over that since we're not using that. So I have this here to activate our Anaconda environment. So an issue though is that I have had a lot of issues with the environment not being activated in my Python, in my Slurm batch file script. And so it may be easier to, let me see if I have it here. Okay, so let me copy this. So because I just had a lot of trouble with activating it. So I actually updated the script you're using is updated on the Slurm. So my apologies. Let me actually create the, I'm just gonna copy what I have from here. So actually I have some more comments in here where you have export Python here. So this is explaining that activating it sometimes fails, like it doesn't work. I don't know why. I never fixed it because I'm just like whatever. You want to put you can hard code the path to your Python executable, and this explains how. So if you need that, so you can activate your environment and then run which Python, and this program which will actually give you the path to a command line program. And then you can just copy that path and put it here. So in this case, let's just say I'm gonna have to load modules. So I'm gonna load Anaconda 3. Oh, didn't like that because I have to type load, and then I'm going to do source activate REU 2021. And if I do which Python, you could see this is the Python path. So you can copy that there. You want to put that here. And then once you do that, that's pretty much all the setup you have to do. So you define your name, you update your job log directory here. If you need to load any other modules, you put that here. This will actually echo a bunch of, it'll print a bunch of stuff out about the job. So it'll be in your log. So it'll be like the working directory, the job ID, current working directory. And so it gives you some information, how long it's going to take to run, how long it took to run your code, stuff like that. And then here's multi-DPU and then single DPU. So NVIDIA SMI will actually print what GPUs you're using too. So it'll give you all the information about what GPU you have and what's going on. So there's some extra stuff. All of it's not needed to run Slurm, but it's just to help you guys out when you're debugging and things like that. And it explains it here in the comments. And then time, and then you're gonna run Python, the file, and the arguments. And then after this, it'll move your logs to your log directory. You could delete these last two files. You could delete these two and all this job stuff if you don't want to move the logs after, and it should still run fine. Yeah, I'm gonna go ahead and let me just quickly finish this up here because I actually changed this. So Python, I think that's it. I think I filled out everything. So once you fill out everything like that, you should use to run our job. And this is very important. To run our job, we're going to use sbatch and then our Slurm file. But remember, the very important thing is you should be running this from your directory of where your code is. If you run it from a different directory, so if I cd to my home directory, do sbatch test job /job.slurm, it's gonna error out because there's gonna be, it'll run, but there'll be some pathing issues because it won't be able to find your code and stuff. So you should run this from the directory of where your code is. So that's important. And you can, and this is for running Python programs, which probably all of you will be doing, but if you could use sbatch to run any program. So as you can just change it out in the script when you do where the NVIDIA SMI Python thing, you can change that. So hopefully this works. So when you run this, you should see submitted batch job 97558. So it runs instantly, so you're not going to see the test files here. But what happened is you'll see files running here, the job files here. But since it just kind of worked instantly, it's already gone. So if I go to my home directory, I can look through my job logs, and I can actually see hello world.out. So I know this is like a lot of it. As you can see here, if I cut that out, I see I pulled a 32 gigabyte DPU from NVIDIA SMI here, and it printed hello world. And if I look at the error, I could see, there's some stuff about activating currently loaded modules, and then the time it took to run the program. So, and then for using srun, you can, so it's really quick on srun. If you view I'm going to look up the job real quick again, this script. You can actually, all these sbatch commands, you can add these flags and arguments to srun, and it'll do the same exact thing. So if I want to do srun nodes 1, I want to get 1 DPU and task equals 1. I'm just going to run NVIDIA SMI. This submitted a job to Newton, to Slurm on Newton, just to run this program real quick. As you can see, it ran the program and it gave me a 32 gigabyte GPU to use. So yeah, and you can use all the other stuff. So managing and viewing Slurm output files. Okay, so one last thing and then we'll be done. So if you're running a program that's taking a long time to run, you'll see the, I'm gonna go ahead and CD to my job logs real quick. You'll see this, this hello world out. There's also this one, out file. So say the program is running a long time. These two files here will be in a directory of your code where you're running it, as the job is running. So say you want to view the output as the job is running. What you can do is this file is constantly being updated by Slurm with the output of your program. So you can actually watch that file being updated in real time to view the output. So kind of like sudo viewing the output, STEOut. So in order to do that, we're going to use this program called Tail. So there's two programs like Tail and Head. As you probably guessed it, Head you can view the top of a file, and Tail allows you to view the bottom of a file, like the content. So if you have a text file, Head will view the top, Tail will view the bottom. So when you do Tail, there's an argument called, or a flag called tickf. So tickf is follow. So that means it's going to open up the file and follow the output as it gets appended. And then you can do your output file. So as you can see here, this file is already done. So I'm not seeing, it's not no longer being updated. But when you do this, it'll take up your terminal here. So the program is still running. And you'll see the output kind of scrolling by here as your program is running. You'll see that output in real time. So you can watch your program run in real time if you need to. And if you want to get out of it, you can just Control-C, text it out. That's pretty much it. Sorry, I had to rush through the ending. If you need help running Slurm, you can message me on Slack. It might take some getting used to. I know I have a lot in this batch script, and kind of going from what we had yesterday to this is kind of like, wow, this is a big jump. There's a lot of stuff I haven't seen. So I apologize for that, but it's kind of just, you kind of got to get thrown into it and just learn it from there. I mean, so if you have issues, you can message me on Slack, and yeah, thank you.
Well, thank you, Brandon. So I'm going to just speak for a few minutes then. So Brendan, thank you so much for this extremely valuable thing you always do for us. Okay.
Yeah, no problem.
Do not ever think that we underestimate what you do. Okay. So now the students, so I was supposed to come in now, and you're supposed to share your screen with me, each of you one by one, and show me what you've done, right? So I will take a couple of people before 11:30, and then Dr. Mahalnobis comes in. And then when I come back at 2 o'clock, I will see the rest of you then, right? Okay. So who's ready to share a screen with me and show me something?
I can.
Yeah. Okay, so go ahead, Ethan.
All right. Just pull up my.
So Robert, you've given them the power to share the screen, is that right?
Well,
Yes,
if
sir.
he hasn't, I don't know what he's doing. Let's see. Show.
They're sharing. Yeah, they're sharing.
Oh, it's showing it on the wrong screen. Swap presenter and slide view. There we go. So this week was pretty interesting, and I guess a little background for me. This is probably what you know
so look,
already.
look. So this is actually not a preparation for the presentation that you're going to do tomorrow. I do know that there's a strong overlap between what you're going to do. I just want to see your results. Okay, just
Okay,
skip
just results.
directly to results. I just want to make sure that every one of the students, has been doing work, and you have some evidence to show that you did the work. Right? That's it.
Okay, I'll skip to that then. So I did MNIST classification with that, and I had a little Matplotlib graph there that trained really quickly. And next assignment 1, this is where I spent most of my time, CFAR10 and Keras. I found a nice model on the TensorFlow documentation. It got around like 70% validation accuracy.
Okay, good, good.
After that, I decided to change a bunch of things to see how that would affect it.
Sure, that's all good.
And mainly started by changing the architecture, and I increased the number of number of convolution layers before pooling from 1 to 2, and that actually gave us a measurable improvement from 70% to about 73.
Good.
I also changed the number of dense layers.
I would say that I'm ready to move on to the next student now, Ethan. Thank you so much. You did a good job. Okay, thank you.
Oh, okay.
Who's next?
Can I go?
Yes, go ahead. Share your screen with me. Thank you, Ethan. That was good to hear.
All right.
Okay, you can see, right?
Yes, then I can see your screen. Go ahead.
Okay. So this is okay. So this is for the Keras classification.
Yeah.
These are the model observations. This is for Keras CFAR10.
Okay.
I tried it on like 5 different models. Model 5 was the best. These are the other models. These are all the models against each other.
Okay.
This is for the PyTorch classification.
Very good.
CFAR10. Yeah, that's about it. And
okay, good. Good. And of course, when you're presenting to Dr. Shah, he might ask you some detailed questions about each one of these plots and so on. Okay. So just make sure that you understand what you did, right? Okay. Thank you. Who's next?
I can go if that's okay.
Yes, please go ahead, Leah.
Okay, let me share real quick. Okay. Oh no, not again. Okay, wait, there it goes. Where's my PowerPoint? All right, so here's my PowerPoint. So I got the MNIST stuff here. I have two slides for that right now.
Okay.
I have 3 for the CFAR 10 with Keras, just a couple different things I did with that. Okay. And then right now I only have 1 for the PyTorch one because it was taking super long to run on my machine. And now that we know how to do the Slurm stuff, I want to do more tonight.
Very good. Excellent. Okay, good. And then one other thing, by the end of tonight, or maybe even tomorrow sometime, all of you guys will have thought a little bit about the possible projects and so on, right? So one of the things you should include in your report tomorrow is a short half a page, just a half a slide on what topics are of interest to you, okay? But obviously right now that's premature. You don't even know what the topics are. Okay, thank you, Leah. Next person. If you're lucky, we can get, if you're lucky, we can get all 10 of you done like in the next 10 minutes. You just go quickly. Okay, Chu, good. Skip right to the results.
Okay, so yeah, I did MNIST, got about 99% accuracy on that. Okay. With Keras, I built a model in Keras from scratch and got around 78% accuracy. And that was with, I think, 5 convolutional layers.
This is the CFAR10. This is the CFAR10 problem, though, right? Not the MNIST.
Yes.
Okay. Go on.
I also looked at how it changed with sample size and the accuracy increased logarithmically. Okay. And then with PyTorch, I used code that Robert provided,
Yes.
and that used VGG 16 off the shelf, and that had an accuracy of about 93% after 200 epochs.
Okay. Okay. And for all of those topics, VGG and so on, make sure that you're spending a little bit of time in the next 24 hours just looking at some of those things so that if Dr. Shah asks you any questions about them, you're not completely lost, right? Okay.
Okay.
I don't expect you to be an expert at that stuff. It'll take some time to really understand all those things, but just do a little bit of reading on those topics so that you can tell a little bit about what's going on. Okay. Thank you.
I just want to reiterate that point, Dr. Lobo, because it's very important. Guys, if you use that VGG off the shelf, which by the way, nice terminology, Chu, I like that. You have to look at the model and get an idea of what's actually happening in there, because Dr. Shah will say, oh, well, what's VGG? And if you don't know, it's going to be bad. Okay.
Yeah, at the very least, go look at the model of the figure. Like they'll have a figure that tells them all the thing, and you'll see many, many deep layers, hooked up together and so on. That's what you want to talk about. Okay. Just at least know where to find it in case he asks you. You can say, well, at least I got a picture here next to me or whatever. Okay. Okay. Thank you. Who's next?
I can go next.
Go ahead.
I did a whole bunch of experimenting with different setups, and that's I still got to add some things.
Now, just to clarify, you had done some of these things already for the robot vision class. Is that correct?
Yes, but I was in PyTorch. I never did anything with Keras.
Okay.
So this was actually new to me,
Sure.
and I did a whole bunch of experimenting with it. So
okay, good.
And then assignment 1. Basic results. I'm going to change this into a graph. I decided this was ugly.
I understand. Mm-hmm.
And then messing with PyTorch and the VGG things.
So had you done VGG in that robot vision class as well?
No, this was actually my first time messing with it. So
that's funny. That's very funny. Okay, that's very surprising. Okay, but that's okay. That's life.
Sure. Okay,
so you'll obviously be able to relate these things to your PyTorch stuff in the class and so on that you do.
Yeah. Definitely, for sure.
It's all connected up in the end. Okay, good. Yeah. Okay, thank you. Let's go on to the next student.
I can go.
Go ahead.
Okay, so first I have.
So Tess, you're kind of settling into everything. Everything's been going steadily for you.
Yeah, it's good.
That's good. Okay, that's very good.
So I have the MNIST first.
Yes.
So this one got a pretty good accuracy, like 99%.
Sure.
And then I have the CFAR 10 with Keras, and that I was able to get up to 79.
Okay.
And I'll just show I did some experimentation with this for like optimal batch size and like the data set size and that sort of thing.
Okay.
And then for PyTorch, I also used the VGG 16. So that got around 92.7.
Okay.
And then I'll have the research stuff.
That was all the stuff you got from Robert, right? All that.
Yeah, this was from Robert.
Okay, very good. Okay, thank you. Good.
Dr. Lobo, I think that's going to have to be the last one because
okay, not to worry. Okay, then I'll come back at 2 o'clock and we'll talk some more then. Okay, guys. Bye. Have a great meeting with Dr. Malnobis and a great lunch. Bye.
Thank you. All right, guys. I'll see you in the next meeting. Okay. Okay. Bye-bye.
See ya.
Thank you, Brandon.